Hey, welcome to another session of Dr. Susie's Security Second. Today, we're going to talk a little bit about cloud. We'll talk about the definition, we'll talk about the deployment models, we'll talk about the service models. So modern cloud computing actually began to take shape in about 2006 when Amazon Web Services. So that's when they first launched their public pay-as-you-go cloud service, right? But this actual idea behind cloud dates back 60 years before. So in the 1950s and the 1960s, before the internet existed, scientists were figuring out how to share power of massive, expensive mainframe computers, and that's where they started. So in the late 50s and 60s, they created time-sharing systems, and this allowed multiple people to use one giant computer at the same time from different rooms. So in the 60s, a computer scientist named John McCarthy, he predicted that computing power one day be sold like electricity or water, and you would only pay for what you used. In 1969, ARPANET was the early version of the internet that was born. And so at that time, there was a scientist named J.C.R. Licklider, and he envisioned a global network where anyone could access data from anywhere. So then we went to the 1970s through the 90s, and then we started to have technology advancing, and now physical computers could act like multiple virtual ones, right? In 1972, IBM released an operating system that pioneered virtual machines, or VMs. Right. In 1996, cloud computing was used for the first time in an internal business plan by executives of Compaq. Right. So they were brainstorming how all business software would eventually move to the internet. Right. And then in 1999, Salesforce started delivering business applications to users through a website. And this was the start of software as a service, or SaaS. Right. And then, of course, in 2006, then we saw Amazon Web Services launched. Right. And then in 2008, Google came up with their app engine, Microsoft Azure. That was in 2010, right? And then in 2011, there was an official global standard, and NIST actually published the final version of the NIST definition of cloud computing, and that was in September of 2011. So in order for it to be cloud, it has to meet a couple criteria. The first is it has to be able to give you on-demand self-service. The second, you have to have broad network access. The third is it has to be able to pull resources, right? So resources are going to be pulled with multiple consumers with different physical and virtual resources. And the idea here is you're going to dynamically be able to assign and reassign based on consumer demand. So it's going to be not a static, but it's going to be a constantly shifting thing. Now, it's important to know that the customer generally has no control or knowledge over the exact location of the provided resources, right? So once you provision with a cloud service provider, you don't really know where your data is unless you get that into part of your service level agreement. And then we've got rapid elasticity, and this is capabilities can be rapidly and elastically provisioned. Again, quickly in and out, scaled, right? So to the consumer, the capabilities are available for provisioning often look like they're unlimited, and they can be purchased in any quantity, at any time. And then the last part of this, it has to be a measured service, and that's so they can get paid, right? So if we look at this a little bit closer, we're going to blow this up. This is NIST's working definition of cloud computing. And we just hit the top level, the essential characteristics. Right now, we're going to talk about the service models and the deployment models, though not in that order. So let's talk about the deployment models first. All right. So we talk about deployment models. There's like 4 options. So deployments that are private, they're operated solely for one organization, right? And that's expensive. Right. Then you have community, and that's shared by several organizations that have some sort of similar interests. Then we have public, of course, that's made available to anyone, right? And then you have hybrid, which is a composition of 2 or more clouds. So now there is some confusion over about how the cloud is deployed and where it's actually hosted, right? So how it's deployed is our private, community, public, hybrid, and where it's hosted is external or internal. So that gets a little confusing, so we got to blow this up. So you can see that if it's public, the infrastructure is always going to be managed by a third-party provider. It's owned by a third-party provider, and it's located off premises. And of course, it's untrusted. But when you get into private community, you get a whole mismatch, right? If you're private or a community-based cloud, right, that infrastructure can be managed by the organization or a third-party provider. It can be owned by the organization or the third-party provider. It can be located on or off premises, and it is considered more of a trusted situation. And then if it's hybrid, again, it can be both, managed by and owned by the organization and the third-party provider, and it's both on and off premises, and it can be trusted and untrusted, right? So it's a little confusing on that part. All right, next up, let's talk about the service models, right? Software as a service, you're basically renting a service, right? So here we're looking at, giving our app, being provided applications, so you're like renting email, right? A lot of people, the software as a service is their email provider, right? That you would contract with a company to host your email. So an example of this would be Salesforce, right? Then the next level is platform as a service, and this is delivering something, platform, tools, services, but you don't install them on your computer, your local machines. And an example of this is Google Apps. And infrastructure as a service is the next one, and this is where the cloud service provider gives us computational resources, right? An example of this is Amazon E². Now, depending on the model that we pick, it actually changes the security kind of mindset here. So if we look, if we're software as a service, we have no control at all. We have to contract it in with the cloud service provider because we're just renting the software from them. If it's platform as a service, we have a little bit more responsibility in this application, this application of cloud. And if it's infrastructure as a service, we have all the responsibility because we have to build it in. Right. So it's important to know that who's responsible for which part of security as we do this. Now, there are concerns, right? Of course, identity is a big one. A username password is not good enough for a cloud. Users and admins, same thing. Web vulnerabilities, phishing, social engineering, password attacks, all of those are valid concerns for cloud as it is for any other system. Identity as a service, or IDaaS, that is becoming a thing. And, should that include multi-factor authentication, single sign-on for the cloud? So that is a concern. And depending on the cloud service provider, they handle it in different ways. Remote management is a concern, right? So your cloud resources are going to be managed via the internet. So now we got to think about things like virtual private networks or VPN, remote desktops, all that sort of thing. Right? Virtualization, we have to talk about that. So we've got management tools used in physical deployments. They won't work for a virtualized environment. So now we have the potential to compromise a virtual machine hypervisor. And if that hypervisor is vulnerable to be exploited, it can become a primary target. And then if you think about the scale of the cloud, that risk could have a broad impact, right? All right, data at rest, that's another one. If you use cloud service encryption, who has the keys, the encryption keys, right? Who can decrypt your data? And then we have to think about portability. So you want to move to another cloud service provider. Is that allowed? What happens to your data? What if they go out of business? So those are all things we have to be concerned about. And again, cloud tends to be a pretty wide target because of the multi-tenacity, right? Or tenancy, the multi-tenancy. So the idea here is that there's multiple tenants in the cloud and everybody's sharing resources. And because of that, that we have to worry about, it's a larger target. It's a bigger bang for the buck for the attackers. So let's talk about how do we apply security. So, first we have to figure out what needs to go in the cloud. Not everything necessarily needs to go, right? If we're working on specialty widgets that only our company makes and nobody else in the world makes it, maybe we don't want to put that in the cloud, right? And then we have to, that ties in with evaluating the importance of the organization. And then we have to look at all the deployment models and make a decision about what is best for our organization. The same thing with the service models. And then lastly, we have to look at the cloud provider themselves. Are they known? Are they reputable? Do they do audits? Do they share the security audit information with their, customers, right? So when we go to the cloud, we have three options, right? We can accept whatever assurances the cloud service provider offers, or we can evaluate them themselves. And sometimes that's allowed, sometimes it's not. or we can use a neutral third party to conduct a security assessment, right? So cloud providers, they should perform regular, repeated, every 6 months, every year, security assessments and provide those reports to their clients. And they should be looking, these assessments should be, privileged user access, regulatory compliance, data segregation, availability, recovery. All these are topics that need to be, considered, right? We also want to think about the cloud provider's policy and background checks. So you can actually contractually bind a cloud provider to require them to do the same level of due diligence with their contractors as with their employees, right? So again, security assessments, if a cloud service provider isn't willing or they're not able to do a security assessment, maybe that's an indicator that they're not the right service provider for you. All right. Well, thanks for listening. Have a great rest of your day, and I will chat with you next time.